Hello. So in this class, we'll do pre-calc chapter 3 and graphing logs and exponent functions. So let's first study exponential function. Basic exponential function can be written like this. F of x is b raised to power x, where b is the base and x is the exponent. So we see here that base b, it should be always greater than 0 and not equal to 1. And f of x is always positive. So we'll see why b is always greater than 0 and not equal to 1. So let's try keeping it equal to 1. If we keep it equal to 1, then f of x, 1 raised to power x, means anything raised to power x is always 1. And so it will be a constant value. It will not be an exponent. It will neither increase or decrease. So it will be a constant value. It will no more be a exponential. Now, if we keep base as 0 and suppose x is negative 1, so 0, negative 1, 1 over 0, which is not defined anything. So it will not be so it will not take values as negative 1, and therefore it cannot be. So base of 0 is not possible. It has to be greater than 0. Now, if we take negative values like base is negative 4 and suppose x is half, then minus 4 raised to power half, which gives square root of negative 4, which is we know square root of negative 1 is not possible. A real number is not possible. It is I, which is an imaginary number. So therefore, we cannot have base is equal to 1, base is equal to 0, or any negative number. So it has to be greater than 0 and not equal to 1. Now we see that fx is always positive. So we see f of x means basically b raised to power x is always positive because as we said, x can be on all real numbers. Okay, x is all real numbers here. So if we take positive exponent, so suppose this is 2 raised to power 3, exponent is 3 positive, greater than 0. So we get 8. If we take less negative exponent, suppose 2 raised to power minus 3, then 1 over 8, then this is also positive. Okay. Then if the exponent is 0, because it can be all real numbers, so 2 raised to power 0, that is also positive. And if we take fractional exponent, suppose x is half, 4 raised to power half or square root of 4. So that is also positive. So in this case, we can see that the f of x, basically the value of the exponent function is always positive and greater than 0. But base, it is greater than 0 here and is not equal to 1. Okay. So let's graph a basic function, exponent function, y is equal to 2 raised to power x. Now we are graphing the basic function y is equal to 2 raised to power x. So we see when x tends to negative infinity, y will be 2 raised to power negative infinity, which is 1 over 2 raised to power infinity, and anything raised 1 over infinity, we know it is equal to 0. So when x tends to negative infinity, y will tend to 0. This is the end behavior. And so suppose if we graph here, it will be like this. It will not be equal to 0 anytime, but it will be to 0. It will approach 0. Okay, like this. Now let's do other thing before graphing in detail. If x tends to infinity, here it is 2 raised to power infinity, and 2 raised to power infinity is infinity. So what we got here is if x tends to infinity, y tends to infinity. So this is the end behaviors. Now let's find some points. When x is 0, this is y is equal to 2 raised to power 0, 1. So we got 1 point. When x is 1, 2 raised to power 1 is 2. So that's another point. If x is negative 1, y is 2 raised to power negative 1. So it will be half. So now we have got these points. So let's graph. And this will be the horizontal asymptote. Y is equal to 0 is the horizontal asymptote. So horizontal asymptote is y is equal to 0. We see here domain is negative infinity to positive infinity and range is 0 to infinity. And we plotted here the points. So this is the graph of y is equal to 2 raised to power x. Now let's see log. We know that log is the inverse of exponents. So we see that we have written argument is always greater than 0. So suppose if we keep argument as negative, so this is argument. If it is like log base 2 of negative 8 is y. If we change it into exponential form, 2 raised to power y is negative 8. So no power of 2 can give negative 8. So it's not possible. That's why a negative argument is never possible. Now, if we keep argument as 0, so this will be log base 2 of 0 is y. So it will, if we change it as an exponent, it will be 2 raised to power y is equal to 0. So we see it, even if we keep y a high negative value like negative infinity, so 2 raised to power y would tend to 0 in that case. 2 raised to power negative will be 2 over infinity, which will tend to 0, but it will never be equal to 0. So that's why argument uh, is 0 is not possible. So that's why our argument will be always greater than 0, not 0 or not negative. And for the base, we already know, we have done it in the exponential, that it has to be greater than 0 and not equal to 1. So this was our exponent graph. Okay, now let's draw here the graph of log function. We know log function is inverse of exponent function. So all and x and y values interchange now. So we know that the log function, if we have to graph this, this is inverse of the function which was given here, y is equal to 2 raised to power x. And we know that x is greater than 0 and y is all real numbers. Here, log can have values which are all real numbers, that is negative infinity to infinity. So as x tends to 0, y tends to negative infinity, and as x tends to infinity, y tends to infinity. And because it is inverse, so we got these values when x was 0, y is 1, when x is 1, y was 2. So we can interchange because it is a inverse function. So now 0, 1 becomes 1, 0, 1, 2 becomes 2, 1, and negative 1 and half becomes half negative 1. So let's graph log function. So we see that this blue color is the log graph, log base 2 of x graph. And here we interchange the values which we got from y is equal to 2x here, 1, 0 here, 2, 1 here, and half negative 1. And domain here is all values greater than 0, and range is from minus infinity to infinity. And the vertical asymptote here is x is equal to 0. So we see here that log is the inverse or exponent, and it is reflected over a line which is x is equal to y. We can see this is a line, x is equal to y. And the vertical asymptote here is x is equal to 0. Okay. Now let's do one more problem here. Hello. So we have to graph this function f of x minus 2 log base 2 of x minus 1 plus 3. So first we can study the transformations and take our basic graph as log of 2 log base 2 of x, and then explain the transformations and try to graph this. So in this we see our basic function is log of log base 2 of x. So it moves horizontal translation 1 unit, right? So we can write like this. Then vertical stretch by factor of 2. So we multiply this by 2. Then reflection on x-axis. So we multiply by negative to the function. And then it is vertical translation 3 units up. So we can always do like first multiply by 2 and negative. But to be a safer side, I always use pandas rule. So first we do the horizontal, then multiply, and so we never get wrong on this. So this is negative 2 log base 2 of x minus 1 plus 3. Okay. So now let's try to graph it. I will also pull out the points and domain range which we got for log of base 2 of x. So this is our log of 2 log base 2 of x characteristics which we got in the last question. Now we see that it moves right 1 unit. So basically x has moved to x plus 1 here. So we see that it has moved 1 unit right. It means x value is increased by 1. So what it was x here, now it has become x plus 1. So x has become x plus 1 here, and y, we multiplied vertical stretch by 2, reflection in x on x-axis. So y will be multiplied to minus 2y, reflection in x-axis, vertical stretch by 2, and then translation. So each y in this function will be multiplied to negative 2 and then added to 3. And each x of this function will be just added 1 in the new translated function. So let's find the values and try to graph it. So we see that this is the basic function which we had. Y is equal to log base 2 of x, and this is the new function, the transformed function, minus 2 log base 2 of x minus 1 plus 3. So here we see from the previous, when x tends to infinity, y was tending to, when x was tending to 0, y was tending to negative infinity. Here it is plus 1. So x tends to plus 1 when here x was tending to 0 plus, and then when x was tending to plus 1, y is tending to positive infinity because it is multiplied by negative. So negative times negative infinity is plus infinity. And then the other point was half negative 1 here. Okay. So this is now plus 1, 3 by 2, and this is 5. Then another point was 1, 0 here. So this has transformed to 2 and 3. Now this one was 2, 1, which is transformed to 3, 1. And this is when x tends to infinity here, x tends to infinity, and here when y was tending to infinity, here because it is multiplied to negative, it is tending to negative infinity. So let's try to graph this. So this is a graph of log of 2x, log base 2 of x. We can see we plotted the 3 points, half, negative 1, and sorry, this is 1, 0. So 1, 0 here and 2, 1. And uh, when x tends to 0 plus here, y tends to negative infinity shown here. And when x tends to infinity, y tends to infinity. Now let's draw the graph of the transformed function, this one. Okay. So here in this we see the vertical asymptote is x is equal to 1, which is shown here. And the points we got 3 by 2, 5 is here. 2 by 2 comma 3 is here. 3, 1 is here. And the intercept here is x-intercept is around 3.8. So that is here. And we can see that when x tends to 1, y tends to positive infinity. And when x tends to infinity here, you can see that y tends to negative infinity. So this is our graph for the transformed function y is equal to negative 2x plus 1 plus 3 here. Okay. And we can always convert this into exponent function and then get x and y and then interchange y and x and do it as we did in the last class. So please continue practicing and please do more graphing functions, graphing logarithmic functions, and let me know if you need any help. See you in the next class. Thank you.